to take a look at identifying rational and irrational numbers. And before we do that, we need to give you a little bit of background about how they fit together in the number world. First off, there's a whole family of numbers called real numbers, and it's made up of all rational numbers and all irrational numbers. For the most part, up to this point in your life, if you're just now coming into pre-algebra, you've only dealt with rational numbers. And we've just started to touch what irrational numbers are without having told you so far in this chapter. But let's take a look at it real quick. Rational numbers are basically any number that you can make into a fraction. It doesn't mean it has to be a fraction, it just has that possibility of making it into a fraction. A lot of times you'll see it written as a over b, and then they always say that this bottom number, the b, cannot be 0. That's because 1 over 0 is not really a fraction, it's undefined. And that's the reason that they go through to make that little caveat, that little exception of saying, hey, look, any fraction, just make sure the bottom number is not 0. So again, a rational number, any number that can be made into a fraction. Irrational number, a number that can't be made into a fraction. Here's some examples that way you can take a look at them. For rational numbers, -1 can be made into a fraction. 2.1 can be made into a fraction. The square root of 9 is 3, or -3, and both of those can be made into a fraction. So these are all rational numbers. Over here, basically we have an imperfect square root, which means that the decimal goes on forever without a pattern, and we can't turn those into a fraction. We have pi, another number that goes on forever without a pattern. So again, that is irrational because we can't make that into a fraction. 3 is a rational number, but when it's times to pi, it actually gives you a product that is irrational because it's a decimal that goes on forever. And what if we just literally gave you the beginning of a decimal that goes on forever, put some dots on the end, and literally told you this goes on forever, and you see no pattern there because there's no repeating bar. So then we would say, hey, that can't be made into a fraction either. Let's take a look at this in a slightly different way. Here's the best definitions that I can give you. Real numbers are all rational and irrational numbers together. They're combined. If you want to look at how to define rational numbers, here's the most popular definition. Any number that can be made into a fraction. And again, don't overlook this right here. You're going to see it time and time again. The higher up you go in education with math, a over b, it's the format of a fraction, but then they specifically take the time to tell you that this cannot be 0. So any fraction, as long as that bottom number is not 0. That also means that the top could be a 0. We only care about the bottom being 0. We don't care if it's positive or negative, it's just some sort of fraction. Here's another way to look at rational numbers. Basically, we can make it into a decimal that terminates, that means stops. Okay, so if you're looking at what terminate means, it means it stops. I.e., let's take a look at 2.1. See where the decimal just stops at 1? That's a terminating decimal. Or repeats, and you've seen those before. That's like 0.3 with the repeating bar. Now, irrational numbers are basically the opposite of the rational numbers. So if any number can be made into a fraction is rational, any number that can't be made into a fraction is irrational. Or what's the opposite of a number that doesn't stop or doesn't repeat? What if that decimal goes on forever without repeating? Now, at this point, we're 4 minutes into this video and I'm still trying to explain the difference to you. Here's a shortcut, a little cheat right here. Irrational numbers, if you see that pi is involved in any way, shape, or form with the number, it's irrational. If you see any imperfect square root, it's irrational. And then if you can just remember any decimal that goes on forever without repeating, like this one right here, that's irrational. Everything else is rational. So hopefully that'll help you keep it straight. Pause it, write it down, start to memorize it. Let's go through and actually identify these as rational, irrational. If you think you've got it, pause the video, try it, and then we will go through and identify as rational, irrational. All right, look, pi is definitely irrational because we can't make it into a fraction, and it goes on forever without repeating as a decimal. This, we can make it into a fraction, so it's rational. This is positive 5 or negative 5, which we can both make into a fraction. So it is rational. 4.64, we can make that into a fraction. That would become 4 and 64 hundredths. We could simplify that down to 32 fiftieths and then 16 25ths. So there we go, 4 and 16 25ths. And then we could turn that into an improper fraction. Excuse me, that would be 116 over 25. And so literally you can see that we can turn this into a fraction. And so as a result, it's rational. 2/7, guess what? This bottom number is not 0, so this fraction is rational. This one we can make into a fraction, so it is rational. This is an imperfect square root. I can't make it into a fraction, so it's irrational. It's a decimal that goes on forever without repeating. And see this part right here, that pi? As soon as I take that, the 3.14 and the rest of those decimals that go on forever, once you multiply that by 2, it will make it irrational.